afternoon to all. We have all gathered here for a case study discussion on real-time inspection of aerospace manufacturing during the material inspection. Okay, with the help of terahertz sensor. So we know that terahertz sensors operate under high frequency, that is from zero point 0.1 to 10 terahertz. So this lies between the infrared and microwave spectrum. So this spectrum plays a vital role and it is valuable as it can penetrate through non-metallic materials, polar materials. It can measure the material thickness, etc. So here our problem is during the aerospace manufacturing time, what happens is the proper detection of defects is not possible during traditional methods like X-ray and ultrasound process. All these are not safe and it does not give us accurate results. So we are going to make use of this terahertz sensors, which is accurate in high quality imaging, etc. So you're going to give me a better solution on how this terahertz sensors are used in aerospace manufacturing process of quality inspection. Okay, so I'll give you 5 to 10 minutes. Discuss among yourself and get me a better solution. So hope you have completed your discussion. You can start providing the solution. Yes.
So the provided solution for this problem statement is that using integrated real-time terahertz module is that we will be using this real-time terahertz module along the composite material line manufacturing. So by integrating near to the material manufacturing line, we can able to do rapid scanning as well as to detect the faulty areas. And then one more proposed solution is that by using the time domain terahertz pulses, that is so where we can calculate the time delay due to which we can able to calculate a few error areas like crack which will be involved as well as the thickness of some materials.
So especially we focus on subsurface defects. Yes. So where which is not possible with the help of this traditional X-rays and other technology.
So ma'am, we can also use AI. So by using AI in the integrated with the sensor, terahertz sensor, so we use deep learning. So with that, manually we don't want to check for the cracks and all. The AI itself check it, and we can add robotic arms. So the sensor does not need to be in a fixed place. If we fix a robotic arm and other robotic parts, so the sensor can be moved with the help of robotics. So it will be very useful because in AI we use a for like supervised and unsupervised learning.
So you go with deep learning algorithms. Okay. So manual inspection takes more time. So you are telling we can integrate AI with the help of this terahertz sensors module.
Yes, ma'am.
Okay. You know, real-time explanation. For example, in an aerospace factory, the large wing root is made of carbon fiber and which helps to detect the hidden defects. So instead of using slower, risky kind of methods, it will be the best solution. Like in factories, they started to use, and how it works actually, the panel enter into the inspection line. For example, the panel enter to the conveyor with the help of tetrahertz sensor. The tetrahertz sensor scan the panel without touching. It helps to detect all the microcracks, the elimination, the moisture that if it is occurred in the layer, and also high solution gets generated, and AI analyzes the image within 0.5 seconds. And the results, the direct identification rate is 98.2, the rejection is 60%, and wastage is 40%. And the estimated saving at least $1 million per year.
So I'm going to share about the outcomes and benefits of integrating terahertz sensor in the aerospace industry. So terahertz sensor has an accuracy of around 90 to 98% rather than the existing traditional sensors. So it also has higher, faster production cycle and as well as easy to maintain as well as cost efficient to set up. And then next, it's used to detect the physical deformation such as its cutting, as well as any chemical reactions has occur on the physical layers of aerospace components such as rocket boosters, satellite launch vehicles, as well as satellites, etc. By implementing this terahertz sensor in satellite modules means we can detect the flaws as well as physical deformations. By we can reduce the error advancedly and as well as predictively.
So no, one of its main challenges is we have already existing method. So if we if we take the existing method and we have to implement this terahertz sensor, so the cost will be high, and the sensor will easily get affected by the environment, surrounding environment, the temperature, electricity, and so at start it is a high initial cost, but it's very reliable and useful. So if we change it to the errors made in missionaries, they can be easily found at the final stage.
So thus, as per our discussion, so we have arrived at a solution that with the help of this terahertz sensor module integrated along with the time domain spectroscopy and with the help of AI, we can give a better solution in quality inspection of aerospace manufacturing. So thank you all.